Hello juniors, today we're going to see electronic assignment number 14, measuring correlation. This is a continuation of the last class in which we saw bivariate analysis. We made an introduction to that topic. We introduced some concepts such as bivariate analysis itself, then correlation, which is what we're going to center the class today. And we also talked about regression, which is building a model in order to predict future outcomes, okay? So for today, we're going to see measuring correlation. The objectives of the class are two. First of all, determine the linear correlation of bivariate data. And number two, find Pearson's product moment correlation coefficient, also known as R, okay? We're going to see what that coefficient is and what it tells us about the relationship between variables, two variables. So it says, the Pearson's product moment correlation coefficient, denoted by R, is a measure of the correlation between two variables x and y, giving a value between +1 and -1 inclusive. That means that 1 and -1 are included in the interval. It is widely used in the sciences as a measure of the strength of linear dependence between two variables. Okay, so here's the first thing that you should always remember. The correlation coefficient is a value that is between -1, R is the product moment correlation coefficient, and 1, okay? The value of R would always be between these two numbers. So this is important to remember. Okay, then it says the regression coefficient is used to determine how nearly the points fall on a straight line or how nearly linear they are. A perfect correlation will have a regression coefficient R equals 1, okay, +1, meaning that it's a perfect correlation. Normally, in the physical sciences, we would like to have a confidence level of 0.01 or better. That means that a coefficient of R equal to 0.99, that's 99% of confidence, or higher, gives us the confidence to say that a relationship is linear within a margin of 0.01%. That means that I have a margin of error of 0.01% only, okay? So this is very important. When we do experiments, we usually try to get this value of R in order to get results that are reliable, right? Okay, so here it says, if the relationship between the variable is not linear, if the relationship between the variables is not linear, then this correlation coefficient does not adequately represent the strength of the relationship between the variables. So this is very important for you to know. This value of R is only used for linear relationships, okay? We're not using the Pearson's product moment correlation coefficient for non-linear relationships. Okay, then we have this. If we have a perfect positive linear correlation, remember this from last class, perfect positive linear correlation, first of all, positive, linear. Positive means that it has an upward trend, linear that it forms a line, the trend is a line, and then correlation is just the word that we're explaining here. If we have a perfect positive linear correlation, then the value of R is 1. And you see that in this case, all of the points are perfectly aligned in order to produce a perfect line. Okay, so that's a perfect positive linear correlation. Then, if we say that variables have no correlation, we're saying that the value of R is 0. Okay, so no correlation means that R is 0. And a perfect negative linear correlation means that the value of R should be -1, okay? So the values 1 and -1 mean perfect correlation. If it's +1, then we're saying it's a positive correlation. And if we say -1, we're saying it's a perfect negative linear correlation, okay? Then it says here, the R value from Pearson's correlation coefficient indicates the strength of the relationship between two data sets. So when we're analyzing two pieces of data, if we want to prove that they are really connected or correlated, we would say, we would like to get values of r approximate to 1 or to -1 in order to say that there's a strong correlation between the variables, okay? If we get a value which is near 0, then that would mean that there's a weak or that there is no correlation between the variables. Okay, so then it says here are some more data sets and there are values. For example, this case has we're going to see how to calculate the exact value of r, but in this case there's an r of 0.7, which we would say this is a moderate positive linear correlation, okay? If r is 0.3, then we would say this is a weak positive linear correlation, okay? I'm going to write these values here. Positive. It's moderate positive linear correlation. And in this case, it's a weak positive also linear correlation. Okay, then it says for negative correlation, the value of r is also negative. So in this case, we're having a moderate negative linear correlation. There's a negative trend between the values. Or negative 0.3 means a weak negative linear correlation, okay? This, I'm going to skip this for a second just to show you this. This is the way in which we interpret or in which we classify the correlation between the two variables given its r value. If the value of r is between 0 and 0.25, you see that here the value of r is with an absolute value, meaning that it could be either positive or negative. But if the absolute value of r is between 0 and 0.25, we're talking about a very weak correlation between the variables. If the absolute value of r is between 0.25 and 0.5, we're talking about a weak correlation between the variables. If the absolute value of r is between 0.5 and 0.75, it's a moderate linear correlation. And finally, if it's between 0.75 and 1, we're talking about a strong correlation between the variables. And if it's exactly 1 or -1, we're going to say that it's a perfect linear correlation. Okay, so that's the way to classify the variables depending, or the correlation between the variables depending on the r value. Okay, so this is the way in which we can calculate the value of r by applying these formulas, which seem to be a little bit complicated, but just for you to know, this observation is really important. It says in an IB exam, you will always calculate Pearson's correlation coefficient using the calculator, okay? You will never be asked in an exam to apply these formulas to calculate the value of r. You will always be able to use your calculators, okay? So that's just for you to know. The only moment in which you're going to actually apply these formulas is for the math internal assessment or math project, okay? If you do a statistics topic and you need to use the correlation coefficient, you should be able to show how to calculate this Pearson's product moment correlation coefficient by applying those formulas, okay? So that's the only moment where you're going to apply these formulas. Okay, so I'm just going to show you before doing the example, I'm going to show you one last thing, and then we're going to see the example. Okay, so correlation. These are different examples of the scatter plots and their respective R values, just for you to try to visualize how the scatter diagram or scatter plot looks like depending on the R value, okay? So in the first case, if we have a perfect positive linear correlation where the R value is 1, we should be able to see points that are aligned into a perfect line, okay? Then strong positive, R is 0.8, for example. So you see that the points are kind of aligned, but there's some spread between the points, right? It's not a perfect straight line. Then for a weak positive correlation, for example, 0.4, points look more spread, right? but we can still trace the straight line through the points. Zero correlation, we don't see much relationship between the variables, the points. There's a lot of spread between the points, and there is no line which we could trace that kind of describes this behavior, okay? Then weak negative, same thing as positive, but now the trend is going downwards. So here you can see the line. This is called a line of best fit. We're gonna see this in the following classes. Strong negative, same thing as strong positive, but with the downward trend, and perfect negative is the same thing, okay? Here's a TOK question for you to think about. It says, we can often use mathematics to model everyday processes. Do you think that this is because we create mathematics to emulate real-life situations, or because the world is fundamentally mathematical? Try to think about this question for yourself, okay? This will foster your creativity a little bit. Okay, so lastly, what I want to see with you is an example in which we're going to calculate the value of the correlation, and for only one time in your life, maybe, or at least in this year, we're going to calculate the value of R by hand, and then I'm going to show you how to calculate the value of R using the calculator, which is what you will always be doing for your exams, okay? So, the example says, a school basketball coach kept a record of the number of games played, which is variable X, and the number of points scored, variable Y, for 7 basketball players. So we have there the players, the games, and the points. Okay, so this is bivariate analysis because we're comparing two variables, games and points. Okay, you see that we do not have frequency here. So if you do not see frequency and you see two variables, then you should start thinking about bivariate analysis, okay? So, in order to save some time, I have already taken this table, which is solved, in order to directly apply the formula and find the value of the correlation, which in this case should be this value, okay? So, how do we calculate the correlation? If we go back to the formula, I just put it here to have it more handy. You see that it says R equals 2. This is called covariance of xy. I'm gonna write this here. Sxy is what we call covariance of xy. Then Sx is called covariance of x. And xy is what we call covariance of y. We're not going to see the demonstrations of these formulas because this already escapes from the IB program, but maybe if you follow a statistical career later on in university, you will maybe see the demonstration of this formula that we have here. Okay, so we're going to apply that formula. We want to find R, so we need the covariance of xy, and we need the covariance of x and the covariance of y. How do we calculate each of these terms? Here we have the formula. Covariance of xy is calculated this way, covariance of x is calculated this way, and covariance of y is calculated this way. So, first of all, covariance of xy. What do we need to calculate the covariance of xy? First of all, it says the sum of x times y, so we need to calculate we need to multiply the x variable times the y variable, and then sum or add all of the values. Then we need to calculate the sum of the x values, and we need to calculate the sum of the y values, and divide it by n, which is the total number of data we have in our data set, okay? So, let's see that here. The covariance, I'm going to do it smaller. The covariance of xy would be equal to, you see that in this table, the original data we had are just these two columns, right? X and y. And because we know that we're going to use xy, the sum of x, the sum of y, the sum of y squared, the sum of y squared later on, the sum of x squared, and the sum of x squared, we need to calculate all of those values in order to apply the formula, okay? So that's why this table already calculated x squared, y squared, and xy. How do we calculate this? Easy. If we want x squared, for example, the only thing we do is we square each of these terms. 3 squared is 9, 4 squared is 16, 4 squared is 16, and so on, okay? Same thing for y squared. 9 squared is 81, 10 squared is 100, 20 squared is 400, and so on. And last, in order to calculate xy, what do we need to do? We need to multiply x times y. 3 times 9 gives us 27, 4 times 10 gives us 40, 4 times 20 gives us 80, and so on, okay? So we calculate all of those parameters, which we're going to use to apply them to the formula, right? So the formula says that the covariance of xy equals the addition of xy, so we need to go to this column, and we find that the addition is this term over here. This is the sum of all of these values. So what we're going to write there is 915 directly, minus then the sum of x, the sum of all of these numbers, which is 36, right? Minus 36 times the sum of y, which is the sum of all of these numbers, which is 147. So times 147 divided by n, where n is the total amount of data we have in this data set. In this case, we have seven basketball players. Okay, you can count them here: 1, 2, 3, 4, 5, 6, 7. So we have 7 pairs of information. So the value of n in this case is 7. Okay. So then we calculate the covariance of xy, which, if we use a calculator, would give us, just a second, 915 minus 36 times 147 divided by 7. This gives us 159. So that's the covariance of xy. Then we want to calculate, let me erase this, the covariance of x, s of x. What do we need for the covariance of x? It's the square root of the sum of x squared. The sum of x squared is this column over here. We add all of these terms and we get 218. So 218 minus, then we have the sum of x and the result squared. That is the sum of x, which is 36, and that result we squared. So this would be minus 36 squared. Pay attention at the difference there. Over 7, right, which is our value of n. So then we get the value of the covariance of x. Let me erase this. So this would give us, let's see, the square root of 218. The square root of 218 minus 36 squared over 7. This gives us 5.732. I'm gonna write it to 4 significant figures just to have an accurate result. Finally, the covariance of y is using this formula, right? So we're gonna do the same thing. The square root of the sum of y squared, that is this 3927, minus the sum of y and the result squared, so 147 squared divided by 7. So then we get the covariance of y, which would be square root of 3927 minus 147 squared over 7. This gives us 28.983. Okay, so finally, the value of r, let me erase this. Finally, the value of r would be this, s of xy over s of x times s of y, which is the same thing we have here. So by applying that formula, we would get 159 divided by 5.732 times 28.983, and this would give us, I don't know what happened there, but this would give us, there you go, it should give us, let me see, 159 over 5.3732 times 28.983. This gives us 0.957, which is exactly the same result we got here. Okay, so this is the way we calculate the Pearson's product moment correlation coefficient R by hand. Okay, this is how you would do. So what type of correlation is this? This would be definitely a strong positive linear correlation. Okay, so this is a strong positive linear correlation. So we would say that there's a very strong positive correlation between the variable games and points, meaning that the more games you play, the more points you will score. Okay, so that's how we interpret the result in this case. So we would say that's what's missing here. There, let me use a bigger font. There is a strong positive linear correlation between the variables. Remember that x is always classified as the independent variable and y is a dependent variable. So we would say that the more games we play, more points will be scored. That's how we interpret the result. There is a strong positive linear correlation between the number of games played and the number of points scored. Okay, so that's what we just said. Finally, I want to show you how to use your calculator in order to find the value of R. So I put the instructions here, but I think it's easier for you to understand how to do this if I show you using the calculator. Okay, so I'm going to show you using my calculator here. Just a second. So if you go to your calculators, let's see. If you go to your calculators, you would go to menu statistics, which is menu 2, right? Menu statistics. And then I'm going to erase these numbers. We're going to plot into list 1, we're going to plot the x variables, and into list 2, we're going to plot the y variable. Okay, so we go back. If we go back to the table, we're going to plot in those values, right? Let me do that. 3, 4, 4, 4, 5, 6, 10 in list 1, and in list 2 you're gonna plot 9, 10, 20, 16, 20, 29, 43. Okay, once you've done that, let me go back to the calculator. Once you've done that, list 1, list 2, what you're gonna do to calculate the correlation coefficient is go to calc, so that's F2. Then you see that we have 1 var, 2 var, and reg. Okay, if we want to calculate Pearson's product moment correlation, we'll go to reg, which means regression. Okay, so reg, and then you have these different options, and we're always going to use the x, meaning that it will calculate a linear correlation between the variables. You see we have other options such as a quadratic correlation, a cubic correlation, correlation to the power of 4, and so on. Okay, if you press F6, you're going to see other options such as a logarithmic correlation, exponential correlation, a power, a sine, or trigonometric correlation, and so on. Okay, but we're always going to be using, for the IB exams, we're going to use a linear correlation. So press F1, and then you have two options. These are just the way in which you want to see the linear correlation. We usually use the first one, which is ax plus b, where a represents the slope of the function and b represents the y-intercept, if you recall that from the linear functions lessons. So F1 again, to go to this, and there you get all of the values that we need. And what are we looking for in this exercise? The value of r, okay? In the following classes, we're gonna see what all of the other parameters are telling us, but basically they are telling us the values of a and b, which are the parameters of the line, which is a regression line that we're gonna use to predict future values, okay? But what we're interested in now is this value of r, which is 0.957, which is exactly the value that we got by calculating by hand, okay? So this is how you do it quickly using your calculator. And then, okay, we go back to the exercise. So I hope you remembered the steps. If you didn't, I'm gonna quickly write the steps here. It's basically using GDC. This would be menu, stat, list 1 would be the x variables, list 2 would be the y variables, then you go to calc, reg, x, and then press on ax plus b. And then you're gonna have the value of r. Value of r. Okay, so that's how you use your calculator to calculate the correlation coefficient. In case you don't remember, you always have this instruction over here, which basically explains the same thing. Okay, so I hope you understood this. You're gonna be practicing with some exercises during the following days. So in case you have any questions, do not hesitate to ask. I am always available for you in the Google Classroom. See you, juniors.